This screencast is going to work through an advanced stoichiometry problem for AP Chemistry. So in this particular problem, it says that at temperatures above 300 degrees Celsius, silver oxide decomposes to give metallic silver and oxygen gas. Assuming that we have an impure sample of silver oxide and it produces a certain amount of oxygen, and we're going to assume that the silver oxide is the only source of oxygen, and then we want to know what the mass percent of the silver oxide is in the sample. So we haven't necessarily dealt too much with mass percent, but it's just like every other percent, part over whole times 100. So it would be the part of silver oxide that is in this impure sample is what we're looking for. All right, first thing you want to do is write a reaction. So we've got silver oxide decomposing. So that means we're only going to have one reactant. And it decomposes to give metallic silver. Well, when we write metals, any straight metal, remember that these atoms are going to be metallically bonded to one another. So we're not going to write ions here because they're not in ion form. They are atoms attracted to that sea of electrons there in that metal. So consequently, there are going to be no charges when you just write a metal. So since I have a hunk of silver, it is just going to be Ag, not silver ions. And it is also going to give oxygen gas. Now, oxygen gas is a diatomic molecule, so you do have to write that as O2. Of course, our next step would be to balance this equation. So if I balance my oxygens, I need to put a 2 here, and then my silvers, I have got to put a 4 here. All right. Now, let's extract some information from this problem. So they're telling me that I have a sample of impure silver oxide. If I knew the amount of silver oxide, I would go ahead and put this here, but because this is impure, it's silver oxide and some other junk. So I don't know what that stuff is. So I'm just going to write that it's an impure sample of this, and it's 2.95 grams. But they tell us that it produces this many grams of oxygen gas, and the silver oxide is the only source of oxygen. So this is how much oxygen is produced by that silver oxide. Next, what we want to do is we're going to try and figure out how to get that mass percent. We need to figure out how much of this there actually is in that impure sample. So we're just going to use stoichiometry and we're going to back calculate and go from here to how many grams of silver oxide was there originally. So we'll start with what is certain, and we're certain of the amount of oxygen that came out of this reaction. So we're going to, can we use mole ratio? No. We have to use molar mass, and for oxygen gas it is 32 grams in 1 mole. Now we can use mole ratio, and it's going to be in 1 mole of oxygen is 2 moles of silver oxide. And then we're going to take this out to grams, and this is going to be 231.78 grams of silver oxide in 1 mole of silver oxide. So when we calculate all of that, we get 2.65 grams of silver oxide. So that's how much silver oxide is in this impure sample. And if we want to find the percent silver oxide in the sample, that needs to be the mass of the silver oxide, which we just calculated, over the mass of the impure sample, the whole sample, and then all of that times 100. Now our grams are going to cancel out, so our answer will only be in percent, and for this one you're going to end up with 89.8% silver oxide. So it has about 10% other stuff in it.